Hi, this is the ZP Developer Zone webinar, and we do this every Thursday at 8 a.m. London time. I'm talking rather fast today because I'm actually at a conference. I wanted to do this live, but I couldn't do it live because the bandwidth just wasn't there. This happens, at conferences where we can't control it. So often I do this slide. I talk about, you can use the ZP Academy for understanding some of the science that we do at Zimmer Peacock. You can follow our webinars to see some of the, so we can answer technical questions. We have collaborations that run, we have jobs, and we have the ZP Developer Zone website. And we also have workshops. Now, the ZP Academy has two courses that I want to particularly highlight, which introduce you to electrochemical sensing and electrochemical techniques. Now, this week we've had two questions. One of the questions is using an ADI developers kit with some glucose sensors from Zimmer Peacock. And the other question is actually using some, I think, a third-party electrode, and they're activating the ZP glucose activation solution, and they're also using a barrier layer from us as well. So that, and what they're doing is they're getting a certain response at low glucose concentration, but they're not getting a response at high glucose concentration. So we'll also answer that. So question number one, first of all, thank you for sending us the images. It really helps. So I can see the developer's board. I can see you soldered on these cables for the reference working counter, I suspect. You've also sent us images of these electrodes, and what we've done is we've taken a look at the images. We definitely have, and we've also taken a look at your code. So we appreciate you sending the code through. One of the engineers took a look at this. He's pretty senior, and he said, no, the code looks fine. So we don't think it's the code. Now, our ideas for fixing this problem are, we definitely think you're getting liquid inside your connectors. There's this very smearing and smudging going on. It just, it feels to me like that's a mixture of electricity and liquid that causes that. Your reference electrodes may not be in the solution. Whenever we see electrodes getting fried, and fried, I mean, the electrodes are really darkening up. It sort of suggests that there's a lot of current being passed, and that often happens when the reference electrode is not in solution, and so the op amp doesn't know what the hell to do. Rather than the reference electrode not being in solution, it could be just that the cable to the reference electrode is not a good connection. If you don't have a good connection to the working counter, you basically have no signal. But when you don't have a connection to the reference electrode, you can end up with signal, but actually it's just very noisy and very high. So check that cable particularly to the reference electrode. And then lastly, the inquirer is asking about testing glucose solution. Oh, sorry, Coke solutions, Diet Coke versus, let's say, real Coke. Now that works, but it only works in certain parts of the world. And I think it's because the form of sugars that they're putting in there, depending on where they source that from, will have different amounts of glucose in there. So sometimes it doesn't always work. So actually, rather than trying the Coke versus Diet Coke experiment, just use 0 millimolar glucose versus 5 millimolar glucose. 5 millimolar glucose is about 90 milligrams per DL. I'm sorry if you can hear some background noise. As I say, I'm at a conference. But we definitely do see this kind of smudging that you've got going on here. This feels like liquid has got into these connections. Lastly, yeah, you definitely need to be covering up those electrodes and obviously keeping a liquid away from the other end where the electrical connection is taking place. Question number two, they've got a 4mm electrode. I must admit, I don't know what the electrode material is. I'm assuming it's platinum. If it's one of these surfaces where it's kind of carbon with platinum nanoparticles, etc., sort of an activated carbon, if it's an activated carbon surface where you've kind of got nanoparticles of platinum, that could also be a root cause here. But if I was to describe the problem is that they get a signal for something like 2 millimolar glucose, but when they try to go higher to 4 to 6, they don't get any signal. Now, what this looks like is this. So you have a current. This is me imagining what they've actually got. Got current. You just put in buffer, which is basically 0 millimolar. You add a 2 millimolar glucose, the signal jumps up. 4 and 6, you may get a little effect or maybe absolutely nothing. but you basically get all the signal, all the response only on the first addition of glucose, and after that it doesn't work anymore. So what's happening? What's happening is that you're on what's called a generation 1 glucose sensor, I suspect. So you don't have this mediator layer, but you do have the enzyme layer, and you do have the barrier layer. Now, that barrier layer, the first job of that barrier layer is to deflect or block some of the glucose. So the first thing you can do is actually try increasing the barrier layer, because if there's too much glucose that gets through to the enzyme layer, then the enzyme activity is not high enough to keep on responding to the glucose. So if the barrier layer is too thin, you get a lot of signal on the first addition, but then the enzyme is essentially, there's no more activity left in that layer, and any more glucose is just an excess. So you might need to then think about increasing the amount of enzyme in that enzyme layer by basically depositing down a couple more layers. Now, what's happening in that enzyme layer? Obviously, glucose is reacting with the glucose oxidase. We get a reduced glucose oxidase. It reacts with its oxygen. We get hydrogen peroxide, and if you were on a generation 2, we'd have a mediator in there. Now, I think you're probably on a generation 1, so therefore we're detecting the hydrogen peroxide directly. It's probably just worth checking that you are at 650 millivolts. I'm sure you are at 650 millivolts, but just check that you are. That could also be a root cause for this as well. So how to fix this situation? So you have your substrate, you have your you have your electrode on there, you're drop casting the enzyme layer on, and you're probably drop casting the barrier layer on. So I would say thicken the barrier layer. That will probably decrease your sensitivity but increase your linearity. If that doesn't completely work, I would increase the enzyme thickness, so you just basically got more, can I call it catalyst, to actually react with the glucose. Check that you are at 650 millivolts, and then I don't know what your electrode is, but if your electrode for some reason doesn't have a lot of active surface, even though it's 4 millimeters, if it doesn't have a lot of active surface, that could also be the limiting factor. Because I know I went through it very quickly on the previous slide, but you want everything to be in excess apart from the glucose itself. And so the electrode surface should be in excess. The enzyme activity should be in excess. I haven't touched upon the oxygen, but the oxygen should be in excess as well. But that's something you can't really control. And in order to sort of control that, that's when I start to say you have to increase the barrier layer. Because oxygen's pretty good at diffusing through polymers, whereas glucose is much bigger, not so good at diffusing through barriers. So I think increase the thickness of the barrier layer, increase the enzyme layer. So questions. We have question number 1. They're using the ADI developers boards. The code looks good. Those connectors look like they're getting wet. And you need to make sure that cable to that reference electrode is good. And I'd also make sure that that reference electrode is getting covered when you do your experiment itself. Question number 2, quick answer is I would thicken up the barrier layer, and if that doesn't work, I would then thicken up the enzyme layer, and hopefully then you will end up with, you might get decreased sensitivity, but you will then end up with increased linearity. And then finally, just want to say thank you. I shall apologize, I've done this very quickly today. I'm at a conference. I like to do it live, but the bandwidth is, here has stopped that, so my apologies. But take care. And if you've got any questions, reach out to us at ZP. All right, thank you very much.